This is the Calculus Pre-Lecture Series. I'm Brandon Ashley, and this video is on U substitution. So before we talk about U substitution, we're first going to recall the chain rule. So if we have the function f of x equal to 3x plus 1 quantity squared, then we can take its derivative using the chain rule, which says f prime of x will be equal to the derivative of the outer function, which would be 2 times 3x plus 1 to the first power, times the derivative of the inner function, which would just be 3. Then we can multiply to give 6 times 3x plus 1, and then expand to give 18x plus 6, which would be the derivative of f. So what does the chain rule have to do with integration? Well, if we want to integrate 5 cosine 5x dx, then we need to find a function whose derivative is going to be 5 cosine 5x. And we might guess, if we let f of x be equal to sine of 5x, then we could calculate its derivative. F prime of x would be cosine 5x, and then using the chain rule, we multiply by the derivative of the inner function, which would just give 5. Which is exactly what we had in our integral. So we get 5 cosine 5x, which means that the integral of 5 cosine 5x dx has to be sine of 5x plus some constant of integration, c. And if we want to generalize what we just did, then we can do a U substitution. So again, if we have the integral 5 cosine 5x dx, then we realize that the problem with this integral is this 5x piece sitting inside cosine. So if we let u be equal to 5x, and we calculate the differential du, which would be the derivative of 5x, just 5 times dx, then we notice that 5 dx is sitting out front here, 5 dx, and we can substitute to give the integral of cosine u, and 5 dx was just du, so we can write du. But we know how to integrate this function. We know how to integrate cosine. It's just sine of u plus some constant of integration, c. And then we can back substitute to get back in terms of x's to give sine of u is just 5x, so we get sine of 5x plus c. And that's exactly what we had before. So now we want to try to do this u substitution on a more complicated integral. So if we have the integral 2x e to the x squared dx, then we want to come up with a u substitution to simplify this integral. And you might try u equal to x squared, because the differential of u, du, would just be 2x times dx. And again, we see 2x dx is sitting in our integral there. So we can substitute to give the integral of e to the u, because u is just x squared, times du. And again, we know how to integrate e to the u. That's just e to the u plus some constant of integration, and back substituting gives e to the x squared plus c.